My name is Kelly Powell. I'm Technical Manager for Invino Engineering LLC, located in Tampa, Florida. And this is part three of the pressurized condensate recovery system, a solution to increasing the steam system thermal cycle efficiency. We talked about standard systems, condensate systems in previous presentation and the cost benefit of implementing a pressurized system. And I just want to go over a couple more things. The pressurized condensate system benefits increases the steam system thermal cycle efficiency by achieving reductions in energy emission, chemical costs, makeup costs, which are calculations from the part two of the presentation goes through all the calculations. The thing in pressurized condensate systems have been utilized for over 40 years in certain industries out there. And a lot of people haven't heard about other industries. We've been using it for 40 years. The biggest thing, it increases a company's profitability, and that's a big benefit. The implementation of a pressurized condensate system, not all steam plants or steam applications can implement a pressurized return system. And the first step on implementation is always having a complete steam balance of the system. And what we mean by a steam balance system is one or two prints showing the total steam system. A proper preliminary assessment, design review, and knowledge of the application are necessary to ensure a successful pressurized system. Unfortunately, there's a number of pressurized systems out there that are not successful. So this happened to be an example of a food processing company, and we had gone in and we found that certain applications could utilize a pressurized system. Therefore, we implemented a pressurized return system back to the deaerator operation and reduced 6,200 pounds per hour off the boiler load, which, if you do the math, at the average cost of $7.50 per 1,000 pounds, it was a substantial energy reduction for the plant. The implementation of the pressurized system, an efficient system will be a constant return system that's controlled to a pressure as close to the boiler operating pressure. In a perfect system, or steam system, for example, operating 150 psi, I could have the return system operating 149 psi because during phase change, latent energy is given up to the process. There's no pressure drop. Unfortunately, a 1 psi differential across the drain devices would make the drain devices very large, and that's not economically feasible. So we have to have a differential pressure, and that we look at the dynamics of the process to come up with. The system elements such as line size, distance, steam trap differential elevations all must be taken into consideration and calculated out. Variables in the system, a typical target for pressurized differential between the steam supply pressures and the condensate return line pressures is typically about 30 to 45%. So if you were a 100 psi system, we'd be running 30 psi to 45 psi in the condensate return line. That would probably be our target. What process can implement a pressurized condensate system? Just a few. Paper machines, corrugated, press operation for all types of industries, tire, particle board, veneers, and the list goes on, plastic. And then rotating dryers for all types of industries, for grain drying, for meal type drying systems, and plastic drying systems. And high temperature processes, we're operating up temperatures above 290 degrees Fahrenheit, can implement a pressurized return system, such as others are steam tracing reboilers. And I can go on with more applications, but this is to give you an idea of the processes that can implement a pressurized system. The pressurized condensate system point, make a very simple point in talking to plants about pressurized systems is that P4, the inlet to the drain device, and again, a control valve or a steam trap, always has to be higher than P5. And, it's a simple statement, but, I explain to people, as long as P4 is greater than P5, that's great. The problem we run into is when P5 is greater than P4, and then the system's not going to work. The process is going to suffer. And you can get water hammer and a number of other issues. So the simplest systems, we go back to okay, we've seen all the benefits, the cost benefits to implement the pressurizer system, and now what's going to cost me to implement it. And we have to understand what components are needed for implementation. The simplest systems require no additional equipment, just piping changes. I mean, we did a project in Indonesia, a very large facility, extremely large facility. We just made piping changes. There was no components added, and the first year savings was in excess of $2 million a year, which was a very large system. The system requires a receiving tank, flash tank, pressurized condensate tank, or a deaerator to receive the condensate back to under pressure, the condensate coming back at pressure. Most deaerators are rated at 50 psi, and deaerator doesn't have to operate at 8 psi. It can operate at 30 or 40 psi. We have deaerators operating at 150 psi. What I'm saying is, a lot of time the components to receive the pressurized condensate is already existing, so it's a matter of just piping changes, which really lowers our implementation costs. Then there's more complex systems, and the more complex systems we put in a flash tank system, which is located here, and a pumping system to pump the condensate back to the boiler operation under pressure and keeping the sensible energy high. And then we put in a thermal compressor here, which we basically thermal compress the steam back up and right back into the steam supply coming back into the process. So this is more complex because I need a thermal compressor, and piping and control system, and a flash tank, and but even with the more complex systems, we were targeting at 2.5 to 2 year payback for it. So, still has a great payback to it, even under a more complex system. The last thing, how do I get started? I want to reduce energy, increase the company's profitability. How do I get started? Understand the current system. Roadmap for the changes, implement the changes, and the last is document the success of the program. And that's a critical thing always, is document the success of the program. So we have documentation, we know how much we save, and we can take that to management and say, this is our savings, and that becomes a very successful program. And last is our contact information here. And, we have short-term impacts of steam system assessment, steam system engineering, steam balancing diagrams, performance bound, steam system performance analysis, training, which is critical on anything, is to have proper training. Long-term impacts, upgrades, process changes, improve reliability and safety. So we have a lot to offer our clients domestically or internationally, and the two top senior engineers, myself, Graham Thornton, are more than happy to help you out and become part of your team. If you have any questions, please contact us. Please visit our website. We have all generic information at our website and a lot of great information on steam and condensate. Thank you.